Welcome to The Explainer. Today, we're diving into a part of AI that's all about something we usually ignore, the connections between things, not just the things themselves. It's a real game changer, so let's get right into it. So, what do these things have in common? It sounds kind of random, right? But the answer points to this hidden web that's basically running our modern world. And the big secret? It's not about the individual people or products. It's all about how they connect to each other. Exactly. They're all networks. Your friend group? That's a network. The atoms in a potential new drug? That's a network too. That eerily good shopping recommendation you just got? Yep, that comes from a giant network of you, what you buy, and what everyone else buys. In the world of computer science, we have a name for these networks. We call them graphs. Okay, so the whole world is basically a graph. This kind of data is everywhere and it's super valuable. But, and this is a big but, for the longest time, most AI just couldn't see it. Like, they were totally blind to these connections. They just weren't designed to understand this messy, interconnected reality. So why is that? Well, think about it. Old school AI, it loves things that are nice and neat, like a spreadsheet with perfect rows and columns, or an image, which is just a perfect grid of pixels. But graph data, it's the total opposite. It's messy, it's chaotic. You might have 10 friends, I might have 1,000. There's no fixed order. And that kind of unpredictability, it just completely breaks traditional AI models. So to tackle this huge problem, we needed a totally new kind of AI, one built from the ground up to understand these messy networks. Enter the Graph Neural Network, or GNN for short. And the way it thinks is, honestly, it's brilliant. It's based on this super intuitive idea called message passing. And the best way to get it is to think about how a rumor spreads. Okay, so step one. You listen. You hear what your immediate friends are saying. Step two, you think. You mash up all their stories with what you already believe. And step three, you speak. You form a new updated opinion and then you share that out. That's it. And you just repeat that cycle a few times. This whole listen, think, speak thing is what we call message passing. After a couple of rounds, each person or node in the graph gets a really deep understanding of their little corner of the network. They don't just know about themselves anymore, they have a sense of their friends, and even their friends' friends. It's all thanks to these messages flying around. Okay, but here's where it gets even cooler. Just like people, not all GNNs are the same. They don't all listen or think in the same way. So what we've ended up with is a whole family of different GNN models, and each one has its own special strategy. Let's take a look at a few of the big ones. First up, you've got the GCN, or Graph Convolutional Network. This is kind of the baseline model. It's simple, it just takes the average of all the messages from its neighbors. Then there's Graph Sage. This one is the smart, efficient one. You see, if a node has like 1 million neighbors, talking to all of them is impossible. So Graph Sage cleverly just samples a few of them. This is huge because it lets it work on absolutely massive graphs. We're talking billions of nodes. And finally, there's GAT, the Graph Attention Network. This is the selective one. It doesn't treat all neighbors equally. It actually uses a cool mechanism called attention to figure out which neighbors are the most important and then focuses way more on their messages. All right, so this tech is clearly powerful, but where is it actually being used out in the wild? The thing is, GNNs are probably already a part of your daily life, and you don't even know it. Take recommendation engines. When a site like Pinterest shows you something new, it's doing something way smarter than just looking at your past likes. It's using a GNN to see this gigantic, complex graph of all the users, all the pins, all the boards. And by understanding the connections between everything, it can find stuff that you're going to love, but that you would have never stumbled upon by yourself. And the scale here is just mind-blowing. 300 billion. That's how many connections and interactions Pinterest's GNN, which is called Pinsage, has to sort through to make a single recommendation. That's a number so big, it was basically science fiction before GNNs came along. They're also becoming amazing fraud detectives. You know, a single sketchy transaction might look totally fine by itself, but a GNN can zoom out and see the whole network. All the accounts, all the money moving around, it can spot these faint, coordinated patterns that show a sophisticated fraud ring at work. It's the kind of stuff that's totally invisible if you're just looking at one transaction at a time. And this one might be the most important of all. GNNs are speeding up actual scientific breakthroughs. Think about drug discovery. A molecule is basically just a graph, right? You've got atoms and the bonds connecting them. GNNs can look at that molecular graph and predict things like, is this compound going to be toxic, or will it actually fight this disease? This is speeding up the hunt for new life-saving medicines in a massive way. Okay, let's pull all this together. What are the big things you really need to remember from all this? So here's the bottom line. The world's most important data isn't in neat little rows. It's in messy networks. GNNs are the first kind of AI that can actually think in this network-style way by passing messages around. And while there are different flavors, some average, some sample, some pay close attention, they're all already changing everything from how you shop to how we find new medicines. The really big deal here is that by finally understanding connections, we've unlocked a whole new layer of AI intelligence. And look, this technology is still incredibly new, but its impact is already huge. It really makes you wonder, right? As our world gets more and more connected, what kinds of impossible problems are we going to solve next? Now that we have AI that can actually understand it all? That's the real question, and GNNs are helping us find the answer, one connection at a time.